Okay, this is the second and final video for the integumentary system. In this one, we're going to do everything related to the accessory organs. And of course, they are located in the skin themselves. For the first accessory organ, let's talk about hair. So, yes, we have hair-bearing skin. When we look at a hair, the deepest part of the hair, this part that's really round at the bottom, this is called the hair bulb. It's either located deep in the dermis or it can be in the hypodermis and the adipose tissue. The hair bulb is where the hair grows from, and then it will grow upward towards the skin surface. The hair root is the part of the hair that is still within the skin. So the hair root includes the hair bulb, okay? So the hair root is all of this part. It's the part that's within the epidermis and the dermis. And you notice that the hair root is surrounded by these epidermal cells, which have come down and surrounded it. And these cells are known as the hair follicle, this sheath of cells that completely surrounds the hair bulb and the hair root. When you pull out a hair, you do not pull out the hair follicle. You just are pulling out the hair root and the hair bulb itself. Now, the part of the hair that you can see, the part that you can cut, the part that you can shave, that is the hair shaft. It's the visible part of the hair. It is not in your epidermis or your dermis or your hypodermis. And then if we look at the hair shaft under an electron microscope, you can see that it is all dead keratinocytes. Yep, that's all it is. And when you're putting conditioner on your hair, all you're doing is smoothing this stuff back down. All right, now, did you know that every single hair in your body is attached to a muscle, which is attached to the to your skin? And this muscle is called the arrector pili muscle. Now, normally, this muscle is relaxed. And because it's relaxed and you're warm, your hair falls down slightly. But when you are cold, the arrector pili muscle will contract. And when this muscle contracts, that makes your hair stand on end. And this contraction pulls on the lower part of your epidermis, and that gives you goosebumps. So every time you see goosebumps now, you need to be thinking your arrector pili muscles have contracted. So know the name of this muscle. Okay. Now, the whole reason for the goosebumps, the arrector pili muscles contracting, is when these hairs stand up on end, instead of the hairs being a flat little surface, it now is a bigger surface. So think like a polar bear or a wolf or your dogs or your cats. And so now you have trapping of warm air for quite a distance surrounding the body. So the whole point is to warm the air close to the animal's body. Another accessory organ are your glands, and we have two different types of glands. We have sweat glands. You can tell sweat glands because if you look at pictures, you will see what looks like a tube that's all coiled up. So tubes that are all coiled up, those are your sweat glands. The other type of glands, instead of giving you sweat, which is a watery-based substance, give you an oily-based substance, and these are known as sebaceous glands. And the sebaceous glands are only surrounding hair, roots, And these, instead of being tubular structures, are blobs. Do you see this blob thing surrounding this hair and this other blobular thing surrounding a hair? These are both examples of sebaceous glands. So let's look at these two types of glands in a little bit more detail, starting with the sebaceous gland. Every single hair in your body, every single hair follicle has one or more sebaceous glands. The whole point of a sebaceous gland is to produce the oily substance. The name of the oily substance is sebum. That's where this gland got its name. Sebaceous is from that word sebum. So sebum is an oily substance, and as the hair grows out, it coats the hair and lubricates it. And the whole reason for this coating is it decreases the chance of bacteria and critters to grow on the surface of the hair. So what do? We shampoo the hair and strip off the sebum. And now we have dry, brittle hair. And so then what do? We have to put conditioner back on it. So just let your sebum coat your hair. Let it do what it's supposed to do. Quit shampooing your hair nearly as much and let your sebaceous glands kind of get in symbiosis with your hair, and you'll find that you'll actually end up with less oily hair than you do when you are washing your hair every day. Now, if this sebum gets near the surface and sits there and gets oxidized, that's going to give you a blackhead. If, on the other hand, it's not oxidized, if, for instance, you have keratin that plugs the top of this, then you end up with a whitehead instead of a blackhead. If this gets plugged and there's bacteria underneath, which is what happens when you go poking and trying to pop stuff, then you can end up with acne underneath. But I'm not going to ask you about acne on the test. That's just there for your own edification. Now, in contrast, let's go back to those tubular sweat glands. We have them on all regions of our skin, and most of them are going to open to the surface of our skin. But after puberty, we have them in our groin and axillary areas as well. And there they are opening to our hair follicles. So our hair follicles in our groin area and our axilla not only will have sebaceous glands after puberty, but also will have these specialized sweat glands. And it's these glands that give you that musky smell that you can get after puberty that you don't have before puberty. And that's why, because these glands aren't active before puberty. So it's two different kinds of sweat glands. You don't have to know the names of the different types of sweat glands. But all sweat glands play a role in modifying temperature, and here's how they do it. When temperature rises, they become active, they start secreting sweat, and so the sweat basically is absorbing the body heat, and when it evaporates on the surface, you are dropping your body temperature. Okay, moving on to other things that your body has in your skin for it, and those are your sensory skin receptors. So this picture shows 7 different types. We are going to talk about 6 specific types. So let me go through them one by one. The first one are free nerve endings. You'll notice these pictures are totally different than when I talked about sensory receptors in the nervous system, and that's because I need you not to memorize pictures. So go back, look at pictures of skin, and make sure you understand. Now we are going into more detail than we did before. So free nerve endings can be in the epidermis and in the dermis. And yes, as we talked about before, they can sense heat or cold. Some people think the cold ones are more superficial than the heat ones. Yes, we know we have more cold receptors than we have heat ones. They generally look pretty much the same. Maybe there's a little bit difference. We also know we have free nerve endings that can recognize itch and also tickling, and also we're going to talk later that pain and some other ones are actually free nerve endings. So these are showing free nerve endings in the dermis, and here is showing free nerve endings going up into the epidermis. Okay, so nociceptors, pain receptors, as I said, are also free nerve endings in the dermis, and they are responding to released chemicals from damaged cells. And for us, basically, I said you didn't have to know the names of any of the chemicals except substance P. I also want you to realize that there are other molecules that we can apply to the surface of the skin, which will trigger these. And so like when you're doing something like applying icy heat or Tiger Balm to the surface of your skin, you are applying those exogenous molecules to trigger this as well. The way non-steroidals, so think aspirin, Aleve, Advil, reduce the pain is by interfering with production of these chemicals. Now, not only can free nerve endings give us pain, but any stimulus that's strong enough to cause tissue damage can cause pain. So this includes all the different types of the receptors for heat and cold, as well as those we'll talk about later on that are related to touch and pressure. If you give a hard enough touch or a hard enough pressure or hard enough vibration, or hot enough heat or cold enough cold, you can cause tissue damage. And yes, you will recognize it as pain in your when those messages get to your brain. All right. So going back to those Merkel cells we talked about, that fourth type of cell in your epidermis. If you recall, the Merkel cell was a cell in the basal layer of the epidermis. When we put the Merkel cell with its sensory nerve ending, then we call it a Merkel disc. For this class, I don't care if you call it a Merkel cell or a Merkel disc, but the cell is actually the name of the cell that's in the epidermis. Okay, so this is in the epithelium. So you know it's in the superficial part of the skin, and it's going to be in both hairy skin and hairless skin. But because it's in the superficial part of the skin, like right here, here's the blue cell, it's the Merkel cell, it's not going to take much to activate the sensory receptors. So for this one, it's light touch. Think of a feather going to the surface of your skin. Think of somebody barely touching the surface of your skin. That is what's activating your Merkel cells or your Merkel disc. The second type of sensory receptor I want to talk about is the Meissner corpuscle. This is what we call an encapsulated nerve ending. So it's not just a free nerve ending, and it's not a cell. What it is we have a nerve ending that now has a connective tissue capsule around it. So here's what it looks like. Here's the nerve coming up. It's got a myelin sheath, and here's the end of the neuron. And now we have a connective tissue capsule around it. And that connective tissue capsule has these collagen fibers. And look, it's way up in the dermis. So it's just below the epidermis. Okay. So it's in the uppermost part of the dermis. And we have tons of these, as I said before, in our fingertips, our lips, and our tongue, and our nipples, and our hairless genitalia, especially our penis and the clitoris. Okay, so here's what it would look like in a photomicrograph of your skin. And then here is one up close and a higher power so that you can see what that capsule looks like, kind of like the cotton bulb part of a Q-tip. So what do Meissner corpuscles sense? Well, they tell us where we have been touched. Okay, so they have this receptive field, and so if you will be activating them. And so if you are in a part of a skin that has lots of them like these, and I touch you in that general area, multiple ones of them will be activated, so you can know exactly where you have been touched. And you can tell if you have been touched by more than one thing. Whereas if you're in an area of your back where you don't have very many of them, then you cannot localize it very much. And so that's why these Meissner corpuscles, because we have these areas where we have many of them, are really good for telling us 2-point discrimination in our fingertips, where we really want to do that 2-point discrimination, because that's what helps us to be able to, write really tiny little letters and numbers and draw pictures. Okay, the third type are the Pacinian corpuscles, and these are way deep in the dermis, or as this one is showing, it's in the adipose tissue, so it is in the hypodermis, in the subcutaneous tissue. When we look at it, it has these onion-like layers of tissue, and it also has a capsule surrounding it. So we have an axon of a sensory neuron, which is myelinated, and then the end of the neurons doesn't have myelin, but it has these layers with this gelatin-like stuff between it. You don't have to know it, but then it has a capsule around it. So in a photomicrograph, you can see the epidermis up here. Here is the dermis, and here is Pacinian corpuscle. This one is deep in the dermis and the epidermis, and this one is so deep, it's practically down in the muscle. Okay. So Pacinian corpuscles, when you deform this capsule, you actually have to push on that capsule, deform it to generate the nerve impulse. So it takes quite a bit to deform that capsule because of all the layers in it. So what is going to deform it is deep pressure, and significant deep pressure, but much more so is going to be a high frequency vibration. Okay, so that's your Pacinian corpuscle. The next sensory receptor is a Ruffini corpuscle, and we haven't talked about this one yet. So Ruffini corpuscle is this thing here that looks kind of like a UFO in the middle of the dermis here. So this also has a capsule around the end of a neuron, just sitting right there in the middle of the dermis. And this one gets activated from continuous pressure. So if you have your legs crossed or your arms crossed all the time, or if somebody's leaning on you, you will get impulses from your Ruffini corpuscles. And here's what's really interesting with a lot of these sensory inputs. You get a lot of input right when they're stimulated. But except for the with most of these, what happens is over time, they quit giving you as many impulses. It's pretty much like the change that gives you a lot of these impulses. So the continuous pressure is going to be giving you impulses. So like right away, it's kind of like, all right, you've got some pressure, here's an impulse. And then as it continues to get impulse, pressure, you're going to continue to get impulse, pressure, impulse. And then as the pressure continues, the impulses are going to continue fading off unless there's a shift. Okay, so if you shift, then you're going to start having impulses all over again. All right. Another one is a root hair plexus, where basically it's a free nerve ending that's wrapped itself around either the hair bulb or the hair root. Whether it's the bulb or the root is still called the root hair plexus. And what happens is when that hair bends, or when that erector pili muscle contracts and makes that hair stand up, it senses that movement. So a root hair plexus senses movement of every individual hair. So yes, gentlemen, when we ladies were in grade school with our long hair and it was bugging you because it was sitting on your desk and you pulled on one hair, and we tattled to the teacher and you said, oh, you couldn't feel me pulling on one hair. Yes, we could feel you moving just one hair because we had a root hair plexus whose whole job was just to sense the bending movement of that one individual hair. Okay, so we're done with those, and now let's go to our last accessory organ, and that are our fingernails. Those are our fingernails and toenails. So when we look at the nails, there's lots of parts. We're not going to learn all of it, but here's what we are going to learn. The nail is actually called the nail plate. Okay. And where the nail plate grows from is the nail root, which kind of makes sense. A tree grows from its roots. The nail grows from its root. And notice that the root is underneath epidermis and dermis and is actually in subcutaneous tissue. Now, the cuticle is actually a fold of skin that is hiding the nail root. So this is the cuticle. So the cuticle is epidermis. And then the cuticle sticks to the nail plate as the nail plate grows out. So if you're going and you are getting your cuticles trimmed, ladies, do not have them cut, have them pushed back. Okay, so your cuticles are epidermis. All right, the lunula is this white moon area. And the reason why it's whitish is because this area of your nail plate, which is close to the root, this is where the nail is growing. So the layer of cells is thicker here. That's the only reason why it's whiter. And your nail, because as it grows out, it gets abraded and it gets thinner as it goes distally. Now the nail bed is the skin that is nourishing the nail plate that lies on top of it. So the bed is underneath the nail. So it's this part right here. This is where the nourishment for the nail plate itself is. Okay, so that's it. So that brings us to the question. When you're taking science classes, when you're taking a full load, when you're trying to work while doing that, should you be getting manicures? And if you are getting manicures, what should you be doing? And how much time should you be spending on your manicures as opposed to studying? Well, okay, some manicures don't take a whole lot. They're cute, especially if they're that's kind of cute. This Valentine's Day, special occasion, maybe, but that looks like it probably took you quite a while. This for a wedding, fine. Now, if you're going to the Olympics, all right. Otherwise, you are wasting way too much time. You do not have an entire day to give up, multiple days getting your nails done. But I want to talk about manicures actually ruin your nail. Okay. Whether it's regular nail polish, whether it's a gel nail polish, whether it's a plastic fake nail put on top, whether it's those press-on plastic things that you put on top, all of those things are going to ruin the top layer of your nail plate and basically pull it off. And so you're going to end up with nail plates that are damaged, no matter what. So you need to be smart about your manicures. You even need to be smarter about your cuticles. How many of you have had your cuticles trimmed and you end up with really ratty looking cuticles? Remember, I said your cuticles are there to protect you and they should be attached to your nail plates and be pulled out as your nails grow out. And yet you have let somebody go in with little cuticle scissors or clippers and actually cut them. And have you ever had them cut them so much that you bled? Remember, your cuticle is epidermis, and epidermis does not have blood vessels. So if they are cutting your cuticles and you are bleeding, That means they have cut your dermis or your hypodermis. They are well beyond your cuticle, which means unless that tool was sterile, and it's not because it's touching your nail, which is not sterile, they are introducing germs into your bloodstream, which means you're going to end up with infections. And this is like the best kind of infection it could end up with. And yes, you could end up with such bad infections, you could end up losing nails, nail beds where no nail ever grows back, and or entire fingertips. So, ladies and gentlemen, think about that before you let people and cheap places touch your fingernails. All right, the last thing I want to talk about are tattoos. Tattoos are permanent. That means they're not epithelium, because remember, epithelium turns over. So choose wisely and make sober decisions when you're tattooing. Because maybe making this decision for stars all over your face when you were drunk on New Year's Eve, you thought it was a good decision. And then when you're sober, you thought, maybe not. Or doing words to let people know, maybe not a great decision here either. Also, spell check. Make sure you're spelling correctly. Make sure the tattooist is spelling correctly before they tattoo it. And if you're tattooing yourself or going with a cheap tattooer, oh my goodness, this person has no knowledge, obviously, because they don't even know how to spell knowledge. So then they obviously have no power. But this last person's tattoo, I think, says it all. Clearly, this person probably did make some bad decisions, although it is spelled correctly. So kudos for at least spelling it correctly. All right, with that, we are done with this organ system. And thank you for all your hard work and for learning the terminology and everything. And be sure to send me any messages you may have if you need anything clarified. See you soon.